Dubai is famous for its audacious engineering projects. But now, its neighboring city, Abu Dhabi, could surpass them all. This is Capital Gate, the most inclined skyscraper on the planet. It defies gravity, leaning at almost 5 times more than Italy's Leaning Tower of Pisa. To make it stand up, it'll take some extraordinary engineering that could rewrite the skyscraper rulebook. Situated on the edge of the Persian Gulf lies the Sheikhdom of Abu Dhabi. It's the largest and richest of 7 states that unified in 1971 to form the United Arab Emirates. Abu Dhabi is undergoing one of the biggest makeovers of modern times. Its ruler, Sheikh Khalifa bin Zayed Al Nahyan, wants to join the City Super League. And he's spending over $200 billion to transform his capital into a world-class business and tourist destination. He's already spent a reputed $3 billion creating the most expensive hotel ever built. The Emirates Palace boasts 114 gold domes and is the height of luxury, where rooms cost up to $12,000 a night. And that's not all. He's built one of the largest and most opulent mosques on earth. Capable of accommodating 40,000 worshippers, the Grand Mosque boasts the largest carpet on the planet and the world's biggest gem-encrusted chandelier. But even these structures have not quenched his thirst for the extraordinary. Now, the Sheikh wants a building so spectacular it will instantly become an international symbol for Abu Dhabi. The man appointed with the task of delivering this architectural icon is the Sheikh's cousin, His Highness Sheikh Sultan bin Tahnoon Al Nahyan.
Architecturally, it will be a unique building and positioning Abu Dhabi as one of the cultural hubs around the world, and architecture is part of that overall inspiration and art.
It's a tough challenge. This is a land where extreme engineering is the norm. Neighboring Emirate Dubai has already built the world's tallest skyscraper, the 828-meter-high Burj Khalifa, and an iconic luxury hotel, the Burj Al Arab. Sheikh Sultan signs up a team of architects and gives them a clear brief, not to go bigger or taller, but to challenge the rules of architecture. For Neil van der Veen, one of the concept architects, it's a unique opportunity.
The spirit of the times in the UAE was that anything was possible. Really, you could do anything. We can do something in the architecture that will represent that Abu Dhabi is right at the cutting edge.
The architects look for inspiration in Abu Dhabi's landscape. They find it in the wind-swept dunes and the rolling waves of the Persian Gulf.
We took this idea of wind and water, which are both dynamic, fluid type of rhythms of nature, and we said, how can we capture those in time?
As a result, you get a much smoother phase.
I was really very happy, and when we first see it, because such building, you can get the first impression from the first few seconds.
The team come up with an extraordinary design. A tower that spirals out of the ground to 160 meters. Inspired by a desert whirlwind and the splash of a wave rising over the sand. This gravity-defying skyscraper tilts almost 5 times more than Italy's leaning Tower of Pisa. No single angle of this tower is the same as another. It's a structure guaranteed to amaze.
We really wanted this to happen. They could see a vision suddenly. They could see something that would stand for them. Then there was no stopping us.
Sheikh Sultan wants the lower floors to become the most prestigious office address in Abu Dhabi, with the top 18 levels assigned as a 5-star hotel fit for royalty. But for maximum impact, this landmark skyscraper also needs a prestigious location. The Sheikh decides the tower will stand next to a monument of national importance, the Grandstand. Built by his uncle and founding father of the United Arab Emirates, Sheikh Zayed, it's used to this day for national celebrations. This monument and the skyscraper will link Abu Dhabi's future with its past. Over the past 50 years, this land has experienced extreme change like no other. The discovery of huge oil reserves in 1958 set the wheels of progress in motion. Abu Dhabi's ruler Sheikh Zayed had a vision to unify the sheikdoms and secure their financial future from Western dominance. He then set about using his black gold to create a city that rose out of the desert. Today, Zayed's legacy is all around, and now his son wants to leave one of his own. To transform Abu Dhabi once again, but this time to put it on the world map. Sheikh Khalifa plans a new $2 billion business district called the Capital Centre. Situated alongside the Middle East's largest business hub, the Abu Dhabi National Exhibition Centre. It's the ideal location for an architectural icon. And inspired by its location, the new tower is named Capital Gate. Now, the idea must make the leap from the drawing board to the construction site. The only problem is, no one has ever attempted a skyscraper like this before.
Everyone realized that this is a crazy structure to build, and how are we going to build it?
To make Capital Gate's gravity-defying design a reality, it'll take some extraordinary engineering, and the challenge begins on day one. Its top floors overhang its base by 33 meters, creating huge forces that want to rip the building's foundations out of the ground. At the construction site, project architect Tony Archibald is daunted by the task ahead.
When I first joined the job, I was shown the drawings, and I kind of did a double take, and I wasn't quite sure that I got the correct understanding of the project, and it took me a few moments before I realized what we were about to undertake.
Keeping Capital Gate upright is a huge engineering challenge. There isn't just one solution. To overcome the forces of gravity, it will take a whole range of pioneering techniques. But the task starts with the foundations deep underground.
On one side of the building, the weight is going down into the ground. On the other side, it's been lifted out of the ground. And that's due to the large overhang that we're having to deal with.
The solution requires almost 400 concrete piles that work in two different ways. On the leaning side, half of the piles push the overhang's forces into the ground. On the opposite side, the remaining piles anchor deeper into the bedrock. They resist the stretching forces, trying to wrench the building out of the ground. Finally, to evenly distribute Capital Gate's forces into the piles, a deep concrete slab reinforced with steel is laid on top.
What the foundations taught us is that every single aspect of this building has to be custom engineered.
Excavators dig out a colossal 6,000 cubic meters of sand. And over 8 weeks, hundreds of piles are driven into the ground.
We had an awful lot of piles to put in very close proximity. It was a real difficult challenge.
There can be no let-up on this schedule. Sheikh Sultan wants Capital Gate complete by an impossibly tight deadline. In less than 2 years' time, Abu Dhabi will host the World Future Energy Summit. Over 3,000 delegates from 50 countries and the world's press will convene at the neighboring Abu Dhabi National Exhibition Centre. It's the perfect opportunity to showcase Capital Gate and prove Abu Dhabi is at the forefront of innovation.
They'd have to sit and finish by 90 to accelerate to go.
But this gives the team just 24 months to design and build a unique skyscraper. With the foundations finished, building above ground can begin. But because of the dramatic lean, it will have to be constructed in a very different way to a conventional skyscraper.
We realized once we'd done the foundations that this was going to be the first of many difficult problems.
A normal skyscraper requires a solid core to hold it upright. But Capital Gate's curves will just crack and topple a standard core. Engineers must discard conventional thinking and devise a way to defy gravity. Inspired by the nearby desert landscape and its wind-shaped dunes, architects have designed a curved leaning tower. But it'll take some audacious engineering to stop Capital Gate from falling over. Normal skyscrapers are built around a slim vertical core, which helps to channel the building's weight into the ground.
There's so much overhang on this building, meant that a conventional core, there was no way it was going to work. You just can't build a straight core. It's just not strong enough.
Capital Gate's design would cause a conventional core to bend dangerously. The pull of the massive overhang wants to stretch the core on one side, causing the concrete to tear apart.
You've got to service even though...
No, it is actually 300. It is only 300. Yeah.
It's a maximum of four levels.
Structural engineer Mona Vassi knows it's a serious problem that must be solved.
When I saw this one, I thought it's impossible, it's not going to work. It's just some sketch, somebody left it somewhere. But I always think that the architects, it's easier for them to just draw something, but it's not easy for us to fulfill or satisfy their need.
The engineers developed two groundbreaking solutions. The first part of their plan is to build the core with a curve, bending in the opposite direction to the building's lean. As the structure grows, its weight pulls the core straight. In total, it shifts 350 millimeters, and the effect is significant. The concrete that would have been stretched by the overhang's pull will now be compressed and strengthened.
You build it bent, and then as you add the slabs to the upper levels, it pulls it back into vertical. So basically that whole vertical core is in tension, and that gives it immense strength.
The core grows 4 meters a week, and construction manager Les Fairchild is in charge of building it.
This is probably the most complex core that I've come across. It's built at an angle
and effectively the core holds the whole building up.
The core is built using a technique called jump forming. First, a dense mesh of steel reinforcement is assembled. A mold then closes around the steel to form the shape of the core. The steel mesh is then filled with concrete. Then the mold or form can climb up the core wall for the process to start all over again.
Jump form is a hydraulic platform. Once we've cast each 4-metre level, we simply attach it to some runners and we jump it hydraulically up to the next level.
The core will be strengthened as it straightens. But for the core to carry extreme loads, the concrete must be reinforced using steel rods called rebar. The rebar is installed during the daytime, but temperatures of up to 50 degrees Celsius and concrete don't mix. It dries too fast and could crack. To set at the right speed, the concrete has to be poured during the cool of the night. As the core grows higher, the liquid concrete has to be pumped over longer and longer distances. So the consistency of every batch is first checked in a slump test to ensure it won't block the pipes.
When you first see it coming out the wagon, you can usually tell whether it's a tight mix or whether it's a loose mix, and that's what we're testing for really in the slump test. We simply make a cone, lift the cone off, and depending on how much it reduces in height, tells you exactly what the slump is. The one we just witnessed is 215 millimetres, which is within the specification, so that's good to go.
Whilst the truck drives to the pump, Fairchild needs to get onto the core. He can take the stairs, but 90 metres up is a long climb. He knows a much faster way. Crane lift.
It's going fairly well. We've had a nice continuous supply of concrete, and we're now pumping it up to the upper levels of the building. And the lads are just steadily working away. They actually work from one side to the other in metre deep layers, so they're doing everything right. It's always exciting when we pour concrete. It means it's another achievement really. We're going up another level.
But building the core out of alignment and packing it with rebar still isn't enough to stop gravity toppling Capitol Gate.
What we came up with is a post-tensioning solution where we introduced much more reinforcement into the core wall and then used the tensioning process. Basically that was done by introducing high tensile strands to the centre of the walls. When we reach the designated height, we simply apply tension. We're actually stretching the tendons that fall through the wall, and we're actually pulling them tight, and that's done by a tensioning machine. So effectively what you would have when the tension is complete, when the load was applied to the core would stay intact, and the additional reinforcement would prevent it from falling over.
To post-tension the core, 146 steel tendons are threaded vertically through the concrete. Each tendon is 20 metres long and runs through 5 floors of the building, overlapping each other for maximum strength. When the tendons are stretched, the stress counteracts the pulling force created by the massive overhang, stopping the concrete from tearing apart.
Okay, stop. Okay, start moving.
On site, the team are post-tensioning the core. But no one has ever attempted this vertically in a skyscraper. The long tendon is lifted to the top of the core. The team use the steel tendon's weight to force it through a duct already cast through the core. Once the tendon is in position, the team lock off both ends, ready to tension its individual strands. A pneumatic jack clamps around one strand at a time and stretches it.
It's equivalent to about 5 family cars pulling on one end of the rope.
With the steel tendon now stretched to the right stress level, concrete pouring can continue upwards.
The quantity of cable that's been used is approximately 120 tons and 120,000 meters in length. It's about 44 times the Golden Gate Bridge.
This process is repeated over and over and means the core should withstand the huge loads generated by Capital Gate's extreme overhang. But now, an even greater challenge must be tackled. The building's twisting, leaning design must somehow be turned from theory into reality. And once again, it'll mean bending the rules of architecture. To create Abu Dhabi's architectural icon, Capital Gate needs an exterior curved leaning frame. But once again, the building's extreme tilt creates a problem.
The shape of the building with this very pronounced overhang meant that traditional skyscraper building solutions just weren't going to work. There was no way.
The building design requires it to be thin to maximize floor space and allow for huge panoramic windows. Irfan Ahmed is one of the engineers who has to find a solution.
For structural engineers, always it's challenging to accept the architectural requirement, you know. They always want thinner and thinner and thinner.
Surprisingly, the humble chicken could help with this engineering dilemma.
It is essentially a skin of structure around the outside of the building, not unlike an egg.
An egg can withstand huge loads because it evenly distributes forces down through its shell, which means the shell can be thin, creating more space inside.
So it's very, very thin, it's very, very strong. If I try to crush this egg, you can see that it's actually amazingly resilient. So let's see how resilient. Here I have 170 eggs laid out, and we're going to put load on top of these in the form of grease blocks. Moment of truth. So far, so good.
Each one of these blocks weighs 15 kilos.
So we've nearly got half the weight of a car on here now, on our 170 eggs. Let's see how far we can push this. That's 30 blocks, and I think it's about to go. It's going big time now. This is it. This is the end. No!
These eggs eventually crack under the weight, but they withstood over 450 kilos, half the weight of a family car.
Yeah, we used to have it all around the floor.
Capital Gate can't channel forces with eggshell, but it can use the principle of how it works, using a diagrid. A diagrid is a giant mesh of steel that wraps around the core. Steel beams connect to a node or joint to form a cruciform section. 720 uniquely shaped sections link together to form the thin but immensely strong diagrid. Working together, these cruciforms equally distribute the forces down the outside of the building.
The way it does that is by making a uniform net, so that the forces are very evenly distributed, and that means that we can get away with slenderer sections.
On site, a team of 240 steel fabricators assemble the diagrid. They've built the easier straight part of Capital Gate's base, but now the structure is starting to lean, making installation even more challenging. Each cruciform, weighing up to 16 tons, has a unique geometry and must be crane lifted at a precise angle. If the diagrid is not assembled with millimeter accuracy, the mesh will not channel the loads and the structure could be weakened. The engineers must communicate closely with the expert steel fabricators. They design and manufacture the diagrid 150 kilometers away in the neighboring emirate, Sharjah. Here, cutting-edge construction is the norm. They've built one of Malaysia's Petronas Towers and Dubai's iconic skyscrapers, the Burj Al Arab and the Burj Khalifa. But Capital Gate's revolutionary design pushes even these experts to the limit. On the planning floor, project engineer P. Bhaskaran and his team need bespoke 3D software to tackle the building's highly complex diagrid.
The 3D modeling is done, and any unforeseen criticalities will be very clearly identified in the 3D model.
Each one of the 720 cruciforms is precision engineered, not only to channel huge forces, but to connect with millimeter accuracy to the neighboring cruciforms and the glass facade. But to measure their exact angles, the team used some old school technology, chalk. It might look unsophisticated, but it's highly accurate, ensuring all the elements will join together. To keep up with construction, the factory must produce 18 cruciforms every week.
Constructing such a huge building, and a critical building within the short span, without working 24 hours, it is absolutely not going to happen.
As the skyscraper reaches new heights, the long hours start to pay off.
This design pushes the diagrid technology to its absolute limit, and in fact far beyond what's ever been achieved so far.
Even in your dreams, you're thinking about this project. So once you see the structure coming up, you forget all the long hours you spent and all the sleepless nights.
A colossus is fast emerging from the Abu Dhabi sands. Now, this leaning tower must be clad with a glass facade. And as always with this gravity-defying structure, it's going to require some revolutionary engineering. Glazing Capital Gate's leaning curved frame is a major problem. Covering its unusual contours with curved glass will blow the budget. So the skyscraper's curves must somehow be clad using cost-effective flat glass panes. Fortunately, ancient Greek geometry can help.
Because you've got a complex shape it's an organic shape, it's a curved shape. The only way to model that with straight lines is to use triangles.
Triangular panes can pivot in 3 directions, and when joined together can cover complex geometric surfaces. But because every angle of the building is unique, it'll take 26,000 triangular panes to form the facade. With so many glass triangles to cut, the local glass factory springs into action. Each pane is scored by an automated diamond cutter to an exact pattern. The triangles are then sent along the production line. The team is under constant pressure to deliver enough glass to the site.
Hey, this side, 2 guys, hold it.
After several weeks, 8 diamonds are in place and another 100 standing by. But the glass design is so unconventional, it still has to pass a number of tests to prove it's up to the job.
Because we'd already started the glass installation, the results of this test were absolutely key. Each panel is stacked one upon the other. So if we'd had any kind of problem, we would have had to unstack them, which would have had disastrous consequences for the program.
This is no ordinary glass skin after all. Capitol Gate's core straightens as it grows. The skyscraper will not stop moving until after completion. Normal glass facades can accommodate minute movements caused by wind and temperature changes. But to stop the glass shattering and keep the building watertight, the panels must be designed to shift by up to 20 millimeters.
The scale of that kind of movement is almost unheard of in glazing systems. It's a vast amount of movement.
With glass installation ongoing, construction manager Craig Rooney needs to know the panels will perform.
We don't want to get to the top. We've done it, we've installed it, we think we've done a great job, and then it all leaks.
The panels must be tested to the limit at a DuBai laboratory. A plane engine and many litres of water simulate worst-case scenario weather. Now the moment of truth. Any leaks could be a disaster. And it's bad news.
The first time we got a full water test, we had a leak. The fact that we had a leak was devastating to the whole team and very alarming.
The diamonds connect to each other by a bespoke two-layer seal. The flexible spongy seal allows the diamonds to move and keeps water out. But if any water does seep through the outer seal, drainage tubes fitted at intervals let the water flow away. The panel has failed the test. Water has flooded inside and penetrated the inner seal.
If it was a fundamental failure, we're back to the drawing board, so the cost and the budget and the program all go completely out the window.
The panel is examined. Answers are needed fast. Fortunately, it's not a design failure. They discover a drainage tube is only blocked with sand. The problem resolved, installation can step up a gear. But as always with this audacious building, one problem is solved and another is just around the corner. To give Capitol Gate's five-star hotel lobby the wow factor, architects again plan to push the design to the extreme. Now they want to build an infinity pool and a restaurant, hanging 100 meters above the ground. "18 months into the build, Capitol Gate's design is about to give a new slant on high-rise living. The architects want a pool deck and restaurant suspended in the sky, but it's an engineering headache.
There's so many requirements that architects have that really put us in so much trouble as engineers, but you want to make sure you have a safe structure.
The design calls for a two-story extension, hanging without any visible support. But the pool's water alone will weigh 150 tons. The structure's huge mass means it needs reinforcement.
We needed some supports from below, otherwise there was no other solution. I don't think you can have a cantilever that huge on this building, no way.
The design will only work if it's underpinned with 22 steel struts. They will carry the loads back into the building. But the struts must also look delicate to meet the architect's aesthetic demands. construction site, 90 meters up, the pool and restaurant is taking shape. All of its structural elements are in position, except one. The team are raising its last 6-ton floor beam. It's taken many crane lifts, but one of the highest suspended swimming pools in the world has made the leap from blueprint to building.
See all those lines that you just drew them? They're actually drawing the same thing for you, but with a crane. But the feeling is indescribable.
And the structure's muscular struts and connections are also elegant.
The idea behind these junctions is that they behave like the insects that can walk on water. They're sufficiently light that the surface tension keeps them above the water. So these little brackets dissipate the forces from all that weight.
Capitol Gate is fast becoming an Abu Dhabi landmark. But the taller it gets, the more the weight of its upper floors is a problem. The skyscraper needs to go on a diet. And this time, the architects come up with a clever solution.
The building has lots of visual surprises. And one of the most important ones of those is the internal atrium. It's a kind of a light well that brings light from the sky deep inside the building, and it extends over half the height of the building. So it starts out very, very small at the bottom and opens out in a big funnel.
This cavernous hole is good news for reducing weight and minimizes forces. But the atrium is a double-edged sword. The floors are critical in transferring loads from the diagrid to the core. A giant hole through 18 floors means these loads must find another pathway.
It's a very, very big hole in every single floor plate. So our engineers really have their work cut out.
You don't want to have an opening in your floor. You want to have more concrete, reinforced concrete, to transfer these forces.
The forces need to flow away. And the solution is pioneering. An internal web of steel mirroring the external diagrid.
This is the first time we've ever heard of this being done. The internal diagrid is actually a fundamental part of the structure.
This funnel-shaped internal skeleton carries the forces of an 18-story building down to its tapered base and into the core. But the loads are extremely high for such a small area. To stop the atrium punching through the core wall, the concrete needs protection. The answer? 6 giant plates of steel that brace the connection to the core wall.
The connections are really a wonderful, wonderful piece of engineering. They're 8 meters high. They span 2 floors and they connect back into the core.
The atrium's near completion brings Abu Dhabi one step closer to achieving an iconic landmark. But as the sun goes down, this isn't the only celebration underway. On site, the Indian steel team are holding an annual blessing to the Hindu god Lord Vishwakarma, the protector of architects and engineers. Their livelihoods depend on staying safe, and although they use safety equipment and are highly skilled, working with huge sections of steel at height is never risk-free.
We pay our respect to God and get the blessings from the God. We do that for the safety of all our workers and for the proper completion of the job. Every trade of workers we take, the basic tools they are using on site, that has to be just kept in front of God, and the workers, they feel themselves that they are in safe hands.
The tools are now blessed, and the steel team's morale is high. But the glass installers, lifting diamonds to over a height of 100 meters, are getting the wrong kind of lift from Abu Dhabi's highly unpredictable wind.
If the wind is too strong, then you can feel this in your hands when you hold these diamonds by rope. I always get nervous if I see the panel starting turning. And this makes me always a little bit afraid when I see diamonds going up and starting moving.
Meyer has to act quickly, or this 4-ton diamond could smash into the building. Not for the first time, lifting glass is delayed by changeable weather. At this rate, Meyer won't install the remaining 107 panels in time. But Abu Dhabi's wind isn't the only problem the Capital Gate team face. A last-minute design request comes in from the Sheikh's office that could have serious implications. With just 6 months to go to completion, the Capital Gate team should be on the home straight. But those plans may have to be put on hold.
I had a telephone call saying that we had to put a helipad on the roof, which I didn't think was a joke, but I was astounded that we got this at such a late point in the project.
Integrating what will be Abu Dhabi's highest helipad atop one of the world's most daring skyscrapers at first seems a simple request. But it actually poses 2 serious problems. It'll create new forces that must be absorbed by the already strained core, and unpredictable wind flows that can cause potentially lethal flying conditions.
You get a thing called wind shear, tipping the whole helicopter onto its side, and this is a very real and very dangerous risk.
These rapid wind changes, known as wind shear, can affect the lift on helicopter blades. Aircraft can be blown off course, or literally fall out of the sky.
There is no way that we could have any margin of error on the safety. The only way we could predict what the wind shear would be like on the top of the building was to model it in a wind tunnel.
In London, England, a scale model of Capital Gate is put through its paces in a high-tech wind tunnel. Just as the team fear, within seconds, wind shear conditions appear. Air currents are flowing over the top of the building, but then separate from the surface, spiraling inward to form a realm of turbulence. Wind engineer Leighton Aurelius knows the consequences could be serious.
If the pilots lose control in this random ball of energy here, they may in fact end up crashing onto the helideck, or even worse, onto the tower itself.
I'm sure that can occur.
But that's not all the wind tunnel test reveals. Wind impacting the helipad is also creating huge suction forces.
We're talking about very large forces here wanting to pull the helipad off the top of the building. Something in the realm of several large trucks or big rigs trying to pull this helipad away.
To make the helipad safe, Aurelius and his team have to go against conventional thinking.
We didn't think that lowering the helipad was actually going to be the optimum design, but we see reduced loading on the helipad as well as safer conditions for the pilots to land in.
Lowering the helideck to just 2 meters above the roof dramatically decreases the wind shear threat, and means Capital Gate's core will withstand the additional loads.
We're relieved, frankly. The tests have actually confirmed now that we can actually have it in our original design position, which is very low, which will mean that the profile on the skyline is exactly where we want it.
But it'll take another 5 months to just draw up the helipad's blueprints, and a crane must be left behind to build it. Now, with only weeks to go until 0 hour, the team are installing one of the last glass panels. It's a moment that once seemed a long way off.
In my office I have a plan of all the diamonds we have to install, and in the beginning it looked like I'm in jail and I'm marking the wall with marks for each day. And so in the first time I felt I never will finish this project.
Just 10 months since the first diamond was fitted, the facade now shimmers in the sun. Capital Gate's internal fit-out will take another year. Only then will its 5-star hotel and Abu Dhabi's most unusual office address be open for business. But against the odds, the team have created one of the most extraordinary megastructures on the planet. Capitol Gate twists and spirals out of the ground, soaring to a full 162 meters. It's taken nearly 6 million man-hours to construct, and its overhang is spectacular.
See the building and you stand underneath the underhang. It's extremely impressive. It's a fantastic feat of engineering.
I feel as though I've been here an eternity, but it's probably been the quickest 2 years of my life.
It's been an amazing journey and we've learned so much. And actually I think we've demonstrated that some things that looked impossible or even ridiculous were actually possible.
And Abu Dhabi's past will soon be physically linked to its future by a wave of steel that'll rise over the grandstand and splash up the skyscraper's mirrored glass.
Abu Dhabi is a fascinating part of the world to be at the moment. It says to people we can step outside of the box. We don't have to follow the rules.
With the 2010 World Future Energy Summit just weeks away, Sheikh Sultan can be sure Capitol Gate will show the world what Abu Dhabi is capable of.
This building is really iconic. It catches the spirit of Abu Dhabi and will be part of the postcard image of Abu Dhabi.
The team have achieved what some thought was impossible. A leaning tower that claims the world record for the most inclined skyscraper on Earth.